Hello, everyone. Good morning, good evening, depending on when you're joining from. Welcome to OSDS. It's a beautiful morning here in California, and I hope you are doing well. So let's get started. Before we jump in, I hope you already read the abstract for this presentation. This presentation is about incremental data processing. I'm just going to give everyone a couple of minutes to join in and settle. I see people joining in. Awesome. Let's get started. So as I already mentioned, today's presentation is going to be about incremental data processing, a path to streamlined data engineering pipelines. Before we get started, a quick disclaimer. The analysis and opinions expressed in this presentation represent my own independent work and research. This presentation is not affiliated with or endorsed by Tesla in any way. The overview provided aims to highlight common data engineering best practices, but does not claim to be an exhaustive guide. Implementation of these practices may vary organizations and use cases. Now that we have got that out of the way, let's get started. I want to begin with providing a quick overview of what today's presentation is about. We'll start off by discussing data processing methodologies, then moving on to data engineering pipeline best practices for which you guys are here for. Then we'll double down on incremental data processing. What are the benefits? What are the challenges? And then in the end, I have an exciting demo for you guys. So stay tuned until the end because I can guarantee you that the demo is going to be worth it. Great. So let's get started with data processing methodologies. The first one is full load. I think a lot of you are already familiar with this method. This approach empties the old data and loads a complete new data set on every run. I think this is the most common methodologies for a lot of use cases these days. The pros are easy to implement, low maintenance, simple design. The code is pretty straightforward, but the cons are it's unsustainable if your data volume is rising over time. Performance is somewhat slower because again, your data volume rises over time and you process the full load. And it's also unable to preserve history, which in some use cases is pretty important. Now, moving on to incremental load. This is a more targeted way of moving only the new and updated data between systems. So the pros are faster processing, better risk management, consistent performance. You can store history as well because you have timestamps. Cons are the design is a bit complex, and in case of schema drifts, your pipeline needs to adapt to the newer schema. Okay, then. Moving on to the exciting part, data engineering pipeline best practices. I have 6 principles here listed down, but again, as I mentioned, these may not be the exhaustive list, and you can tweak it a little as you like. But on a high level, these 6 principles have helped me a lot in writing robust data engineering pipelines. The first one is modular and scalable code. These you can think of these as questions as well that you can ask while developing a pipeline. How easy is it to integrate a new data source or logic in your pipeline? So for that to happen, you need to write modular code. Filter data early. I think this is one of the most cost-saving principle, you must say, because you should only bring in the data in your logic which you intend to process. So filter out data early, only process the chunk of data that you're actually looking to get outputs from. Data partitioning is your best friend. This one is my favorite. Partitions are very powerful if you use it wisely. Slice and dice your data for performance and scalability. It is also important to understand the trade-off between having a lot of partitions and having less partitions, right? So you need to understand your data well. You need to understand the skew in your data well. Partitions need to be uniform as well. So once you have a good understanding of your data, you can use partitions efficiently. Pure tasks or unit of work. right? So whatever tasks you have in your pipeline should serve only one purpose, meaning if a task is complete, it should only output one partition for the sake of simplicity. Idempotent, again, this word has been thrown around quite a lot lately, and most of you already know it. You should get the same data regardless how many times your pipeline runs or when the pipeline runs, right? No duplicates from duplicate runs. So that is just a sign of a robust pipeline because you can rerun or on demand, you can trigger a backfill for the duration you want. Uh, and the last one is late arriving data. Handle late arriving data gracefully, and that data should be considered in your metrics as well. Moving on to, let's double down on what incremental data processing is. So incremental loading involves moving only newly or updated data between systems, unlike full loading, which just copies everything. It identifies the data that has been created or changed since the last load or run. This selective approach reduces overhead compared to full load since less data needs to be processed. But only transferring modified portion of the data. Incremental loading is more efficient than completely reloading the entire data set each time. Like we discussed in the first slide, let's discuss the benefits a bit more in detail. Processing the least amount of data possible, like I mentioned, for incremental data pipelines, you only process the data which has been updated or modified since the last run. So the data volume for that task is going to be low. That will lead to the second benefit, which is lower infrastructure costs. And even the third one, faster processing, right? Just because you have less amount of data to be processed, your costs are going to be low and it's going to be much faster. Consistent performance, right? So you are pretty much aware of what kind of data on a daily run you would have, and that would just lead to a more consistent performance. Better risk management. Let's say you have your partitions laid out, you know what data is coming when, and for some reason one of the partition receives bad data. So if you have a well laid out uh, pipeline, only that partition would fail, but the other logics would still go ahead and run. So you would still have metrics for all the other logics. So that's just better risk management. And then you also have storing history, right? So you know what changed when. And so in case you want to debug any of the business logics, you can go back, trace back, and see what changed when. So those are the benefits. Challenges in terms of constant monitoring. Data, incremental data pipelines are generally a bit more complex. So that would require constant monitoring on if your code is handling all the nuances and edge cases for your business logics. Designing and writing efficient code. Writing code for full load is somewhat easier. You can just have a notebook or a script which just truncates the data and loads the new one. But writing code for incremental pipelines is generally a bit more difficult. And the last one, schema drift over time. For full loads, again, if your schema changes, it doesn't matter because you truncate the table and just load a new one. But in this case, you need to be very conscious of the schema you have. It needs to be a very structured table. And if you plan on having changes in schema, your existing code should handle it gracefully. Great. So I've got these two cool visualizations here. So in a nutshell, you can use full load. Let's say if you do a select count star on your table every day, and if the count looks something like this, so this is still somewhat flat. In that case, you can use a full load. But let's say if you do a count star on your data every day, and it looks something like this. So this means it's your data is increasing over time daily. In that case, it is recommended to use incremental load. Great. Now moving on to the exciting part, the demo. And One more thing I'd like to tell you is there's an exercise involved here as well. So I want to give back to all the participants. I'm going to share the GitHub link for the demo, and there are some exercise which you can perform on those demos to make that your own personal project. And the technologies I'll be using is Apache Airflow, Trino, Hive, Superset, Spark. Since you're joining in for a data summit, I'm pretty sure you must be familiar with some of these technologies already. If not, no worries, we've got it covered today. Moving on to just the introduction of what the data set is. I've used a data set from Kaggle. This is around Netflix audience behavior, and the source is VOD clickstream. So quick shout out to them. This data set covers user behavior on Netflix from users in the UK who opted in to have their anonymized browsing activity tracked. It only includes desktop and laptop activities, which is around 25% of the global traffic and is for a fixed window of time. So this data is from January 2017 to June 19. That I think gives you a good 2.5 years worth of data to analyze on. The schema of this data set is as follows. This is just one simple CSV. We can quickly take a look at the CSV. So if you see you have a click ID here, you have a date timestamp, meaning when that click was done, the duration of the until the next click. So this means how long the user stayed on that title. If it's 0, it means they just bounced from this movie title and moved on to the next one. The genre of the movie, the release date, and a unique movie ID and a user ID for each entry. Please feel free to ask any questions if you have. I'm happy to answer them in the chat. Okay, then moving on to the architecture of just on a high level, how this demo is set up. So as a source for our demo, it's going to be a CSV file, but in big data projects, you can think of it as a IoT stream or a separate database as a source. Our storage and data querying is going to happen on Hive. Trino is not a database, it's a query processing engine that we are going to use. And all our tasks and data pipeline orchestration is done using Apache Airflow. And finally, we are going to use Apache Superset for all our visualizations today. If you're not familiar with Apache Superset, you can think of it as an alternative to Power BI and Tableau. Great. Now, moving on to let's jump in to a little bit of code. I've got a DAG set up here. Let me just show the DAG first. Before we even move on to the DAG, all the infrastructure for this is hosted locally on Docker. If you see, I've got a Superset instance running, an Airflow instance running, and a Trino Hive instance running. All the code to spin up the infrastructure is available in the code base. Also the DDL. So if you see how this repository is set up, first you have the data. The CSV here is roughly around 80 MB. So it's not, it won't be on GitHub, but I'll provide a link to download that. All the DDLs that this demo currently uses, you can just go ahead and create those tables in your database. Then moving on to the infrastructure part, we have Docker files to spin up Trino, to spin up Superset, Spark as well. When we come to the exercises part, I'll let you know why I've added Spark here. And then lastly, for Airflow, you have a Docker file as well, and all the logics and scripts are part of the DAX folder here, if you can see. So on a high level, I have the OSDS demo DAX set up here. If we go into the graph, you can see there are just 4 simple tasks. First, I copy source data, and then I process user analytics, infrastructure analytics, and movie analytics. So what I've done is from this simple data set, I've tried to generate movie analytics. user analytics because we have user IDs, and also in general, like infra analytics, or how many the total watch time, the total clicks, just for infrastructure folks to track those metrics. Okay, then. So I'll just go back and forth to the principles I mentioned and what this demo has, right? So if you can see, I'm copying source data. So what this does is from all, let's say, in this case, I think there are around 600,000 records, but a big data system would have millions of records, right? And I have a daily incremental pipeline running. So I do not require all of those 600,000 records in this case. I only need data for that day. So that's when I copy source data here. That means only the data for that day is copied into a separate table, and then it is processed for generating metrics. So as you can see, I've already run this pipeline for roughly 45 days. And currently I'll go through the dashboard as well quickly. So this is Apache Superset. Again, very basic visualizations just for demo purposes. You can see under movie analytics, we have top 10 movies by clicks, top 10 movies by watch time in hours, movie bounce rates. So we can also, since we have the duration there, we can calculate if this was viewed by the user or the movie actually got bounced. User analytics, top 10 users by views, top 10 users by watch time. And I've also implemented, since we have the timestamp, I've categorized it into if it was a evening watch, night watch, or a morning watch. So that just knows when your majority of users are watching. We also have weekly active users in here, and we have some performance metrics. If you're not familiar with P3, P5, P7, they generally mean in a week. P3 means in a week if the user joined in for 3 days, then he's a P3 user. If they have used the platform for 5 days, they are a P5 user. And if they have used the platform for all 7 days in a week, they are a P7 user. So this just tracks the P metrics. And if you have a platform, you would want this chart to go up over time. So this is again a good metric to have. And lastly, for the infrastructure folks, we have like what is the daily watch time, what are the daily clicks, what are the daily views plus bounces, so they can just manage their infrastructure better. And if you see, I think the last date on this is this weekly data. Check for daily. This is 3-1. That's when the pipeline stopped. So actually, the pipeline ran for 2 weeks. You can see start date is 1st January till 1st of March. We're just gonna let it run for another month. And I'm going to quickly go back to Airflow, refresh it. I think, yeah, the updates are now pick up. Now, if you see, there are daily runs. So this will start running. You can see February 28th. Now it will pick up data for each day and try to process it and only process it for that day. And we can again go back to our dashboard. Okay, we logged out. You can just see these metrics have changed. Now we have data for March 4, March 5. Let's go ahead and set it on auto refresh. Let's do 30 seconds. So of course, then on a production level, you will run it every day. But for the demo sake, I'm just running it for a month. And there's actually a lot of data in here. So you can go ahead and play around with it. Let me actually go ahead and set it for 10 seconds. You can see it. live. So you can see these metrics are changing because our pipeline is running on the back end, and all these visualizations are getting updated as they receive new data. I'm just going to let it run for a few more days. I think we were here somewhere. It has run for 3, 4 days. Let's go back to our Airflow tag. Let me quickly check. Sometimes you run out of, if you're running this demo on your local, make sure you have enough memory allocated to it. I think the majority of memory is taken up by Trino and Hive. You can easily replace it with MS SQL or Postgres if you want. But in the spirit of open source, I decided to use Trino. Right, I think so. We almost have another month of data. Let's go ahead, refresh our dashboards. You can see new data coming in. So once you have like setting up incremental pipelines is definitely a bit more difficult than full loads, but once you have set it up correctly, you can definitely see the benefits of it. Awesome. So that was it for the demo. We had a time series analysis, having movie analytics, user analytics, and infrastructure analytics. And now for another fun part, as an exercise, right? Since this is a demo, but I had a few ideas how you can expand this demo and add it to your own portfolio of data engineering projects. So the first one is around, I currently don't have Spark. Technically, in a big data project, you would do all the processing in Spark, and I've just done it using SQL queries. But I've added this Spark infrastructure Docker file in there. So you can go ahead, run up Spark and connect it with your Airflow and do all the processing in Spark. Data modeling, currently, if you see, it's just one big table, but you can easily break it down into like fact and dim tables separately. Add in more data if you want to add IMDb ratings or derive correlations. You can add your own data to this set. You can definitely derive a lot more metrics on this dashboard. While I was making the demo, fell short of time on just thinking of what all I can add to it. You can implement genre related metrics. You can also identify user behavior patterns, like which days of the week users generally like to sign in. You can, like I mentioned, you can add IMDb ratings to the data and derive correlations between the bounce rates and the IMDb ratings. You can identify seasonality for infrastructure management, which days have a lot of watch time uh, versus, or even months or holidays. You can also do a lot of predictive analytics since you have almost 2.5 years of data. I think that's good enough amount of data for some predictive analysis. And then lastly, you can just add more filters and drill downs to the dashboard. Over here, you can actually also have tabs in place for each specific movie analytics, user analytics, and infrastructure analytics. So you can do that as well. So there's a lot that can be done with this demo. So you can just make it your own personal data engineering project to add to your portfolio. And then lastly, just the references. There are some good data engineering blogs in here, which you can give it a read. And the link for all the code for this demo. If you tend to enjoy the repository, go ahead and give it a star. I'd be thankful for that. That's it for today. Thank you. I hope you have a great rest of the day and enjoy the summit. Be sure to check in other sessions as well. Thank you. Bye bye.